Right folks, today I'm going to take you through the straight line masterclass. We're going to go through everything from parallel to perpendicular lines, how to pick off a parallel gradient and a perpendicular gradient as well, straight into m equals tan theta, the alternative version to find the gradient when you're given an angle instead of 2 points, then proving collinearity using the gradients, straight into altitudes, medians and perpendicular bisectors, which are the most common questions for the straight line, and then finishing off with the point of intersection and some exam questions. Now feel free to pause this video anytime to work through the solution. So let's start off with some parallel lines. Now when you think of parallel lines, I want you to think of train tracks. Okay, they're never ever going to meet no matter how far they're extended. Okay, and they're going to stay the same distance apart. They've also got equal gradients. They look like this, okay, with the two arrows showing you that they're parallel. Or on a graph you can see because of the gradients are the same that these lines have to be parallel. Right, so let's look at an example. Now, I'm going to go into y minus b equals m bracket x minus a, but I'm going to hit on that later on as well. Okay, now, you need two things to find the equation of a line. You need a point, which they've given us. Okay, and you need a gradient. Now the fact that they're parallel is telling us about a gradient, but the only other thing they've given us is this line. So what we have to do is we have to rearrange it. 2y is equal to minus 3x plus 7, because we want it in the form of y is equal to mx plus c. Okay, so I'll pick off my gradient here. M is equal to negative 3 over 2. Now, if the gradient's equal to minus 1.5, then the parallel gradient is also equal to 1.5. So using that gradient and the point 4 minus 2, I'm going to find the equation of the line using y minus b is equal to m bracket x minus a that you met in National 5. Okay, so y plus 2 is equal to minus 3 over 2 x minus 4. Now I want to get rid of the fraction, so multiply through by the 2. I'm left with minus 3 bracket x minus 4. Let me rub out that wee mark. That's not meant to be there. Okay, multiply out your bracket. Okay, and I always like to leave my lines in the form of ax plus by plus c is equal to 0, because that's the general equation of the straight line. So I would have 3x plus 2y minus 8 is equal to 0. Now there is nothing wrong with you leaving it as y equals mx plus c, but please remember it has to be in its simplified version, which is why you're not allowed any fractions in it. Okay, so straight on to perpendicular lines. So perpendicular lines meet at right angles to each other. Okay, if two lines are perpendicular, then m1 times m2 is equal to minus 1. That's the proof of it, and it has to be in. You have to write that in whenever you're dealing, or whenever you've just found a perpendicular line or perpendicular gradient. So they look like this. Okay, or on a graph they'll look like this. Okay, meeting at right angles. So let's take a look at it. To find the gradient of a perpendicular line, we find the reciprocal of that line, of that gradient. Now, the reciprocal is just a fancy word to say we flip it upside down and we change its sign. So if we take the number 1, you would have, I use a wee right angle to say that I've got a perpendicular gradient. Turn that upside down, and remember 1 can be written as 1 over 1. So flip it upside down, it's still exactly the same, and change its sign, minus 1. Okay? So let's take a look at the next one, minus 1/7. Remember, turn it upside down, flip it upside down, and change its sign. So because it's a negative, you're going to get a positive. So m is equal to 7. Now it would be 7 over 1, but obviously its simplified version is 7. Right, so negative 5. So minus 5 can be written as minus 5 over 1. So flip it upside down. Now this time I'm going to write m perp, because it's exactly the same. Okay, and I'm just showing you can write different versions in there. So flip it upside down, change its sign. Because it's negative, it's going to be positive, and you would get m perp is equal to 1/5. Okay, so last one, m is equal to 2/3. Again, flip it upside down and change its sign. It's positive, so it's going to be negative, and you get minus 3 over 2. And any time you're writing any one of these in, you then have to write since m1 times m2 is equal to negative 1, because that's the proof of it. It makes it true. Right, so perpendicular lines, let's take a look at an example. Consider the points and show that AB is perpendicular to AC. Right, so what I want to do is I want to find the gradient of AB. I want to find the gradient of AC, okay, and hopefully I'm getting the reciprocal for AC. So AB, it's y2 minus y1 over x2 minus x1. So I'm getting 4, no, let's try that again. I'm getting 5 over minus 4. Okay, so if I find the gradient of AC, I'm looking for 4/5. Right, so y2 minus y1 over x2 minus x1. I'm getting 4/5. Beautiful. Right, so then I would say, since MAB multiplied by MAC is equal to minus 1, we would say that AB is perpendicular, so, or the lines are perpendicular. Okay. So, equation of a straight line. I know I've already hit on this, but I want to just go back over it, just in case there's anybody that's confused. So, to find the equation of a straight line, so it's y minus b equals m bracket x minus a, you would need a point and a gradient. Okay, and it would be substituted into the line. Okay, I've colour-coded it so, to help you. Right, so what we want to do, let's take a look at this again. So, find the equation of the line which passes through. So, I've got a point, there it's there. Okay, it's perpendicular to the line, and they've given me a line. Now, they've given me the line in the form of ax plus by plus c equals 0. I want that line in the form of y equals mx plus c so that I can pick off the gradient from it. So if I rearrange it, I would get y is equal to minus 4x plus 1, okay, which will give me the gradient of negative 4. Now, obviously, I want a perpendicular gradient, so you would say m perp is equal to, flip it upside down, and change its sign. So your gradient's a quarter. Now, using that gradient, m equals a quarter, and using the point that they've given me, I can then substitute that into y minus b is equal to m bracket x minus a, and give you the equation of the line. So I get y minus 3 is equal to a quarter x plus 1, multiply through by 4, and then tidy it up. Like I said, I like to leave my lines in the form of ax plus by plus c is equal to 0. If you want to leave it as y equals mx plus c, that's fine. Just make sure you don't have any fractions. Okay, so an exam question this time looks exactly the same as the ones that we've done. They've given us it's parallel to it. We want to find the equation of it. They've given us this line and we've got a point. So this line we need to rearrange into the form y equals mx plus c. So as you can see, my gradient here is minus 2/3. Because the line that I'm trying to find is parallel, I don't need to change that. And I'm going to use the point 2 minus 1. So I'm going to sub both of them into y minus b is equal to m bracket x minus a. And I would get y plus 1 is equal to minus 2/3 x minus 2. Multiply out your fraction, so 3y plus 3 is equal to negative 2x minus 2. Multiply out your brackets on the right hand side, minus 2x plus 4, and then tidy it up. 2x plus 3y, I would get minus 1 is equal to 0 for 3 marks. Okay? Right, so into the gradient using an angle. So sometimes they don't give you a point, okay, or 2 points on the line for you to be able to find the gradient. So I'm going to take you back to National 4 Maths when you were first introduced to the gradient, and we told you that we had the vertical over the horizontal, okay? Now, as you can see from a diagram, that angle is created with the positive direction of the x-axis, so positive direction being anti-clockwise into it. Think of your cast diagram when you think m equals tan theta. Okay, so then, if we've got vertical over horizontal, what we can do is we can create ourselves a right angle triangle. Now, if we go back to our National 4 trig as well, we would have SOHCAHTOA, so there's my opposite side, there's my adjacent, with this being my hypotenuse. Okay, now as you can see, there's my vertical, there's my horizontal, so we're looking at opposite and adjacent. So what we're doing is we're bringing in tan. Okay, so this formula is not given on your formula sheet. It has to be learnt. Anytime you've got an angle and they're asking you for a gradient, you would use m equals tan theta. So let's have a look at it in action. Right, so find the gradient of the line shown here. Now, we have to check that this is the positive direction of the x-axis. It is, so they've given us the correct angle. So we want m equals tan of 60. Okay. Now, that's one of your exact values. So you would give me root 3. Okay. Now, if you type that into your calculator, the decimal would be approximately equal to 1.73 to 3 significant figures. Sorry, my 0 button on my calculator wasn't working there. Okay, so let's take a look at another one. This one looks a bit different. This time, they haven't given us the correct angle, but what they have given us in the diagram is the x-axis. Now that x-axis is parallel to this line that I'm drawing in here. Okay, so that creates the same angle. Now, the angle that we want is this one here, positive direction of the x-axis. Now, as you can see, that x-axis is creating a 90-degree angle in there. So because of that, the angle that I'm looking for must be 50 degrees. So again, m equals tan theta. Okay, so your gradient is equal to tan of 50, and tan of 50 is 1.19 to 3 significant figures. Okay. Right, so last one, we're going to turn it around a wee bit. Okay, they've given us the equation of a line. So we need to rearrange this. So y is equal to minus 2x. So we know that our gradient is minus 2. Okay, we also want to find the angle. So we want m equals tan theta. So substitute that minus 2 in for your m. Okay, now to get rid of tan, you're going to find the inverse of tan, but I don't want you to put in the 2. I want you to do shift tan of 2, and then we're going to use our cast diagram. Okay, so shift tan of 2 will give me 63.4. Okay, the angle I've just found is this one in here, just in case you're interested. So this angle here that I'm looking for would have to be 180 minus 63.4. And I would get 116.6 degrees. Okay, right, so let's look at an exam question. They've given us an angle. This is non-calculator, this question, and they've given us a point. So we're going to use both of these to find the equation of the line. So we need to start off, m equals tan theta. Okay, substitute in your 60. Now, as we saw before, tan of theta is an exact value, so you should have root 3 in there. Okay, we're then going to use the point t minus 2, 0, and we're going to substitute this into y minus b is equal to m bracket x minus a. So y, you would have minus 0 in there, is equal to root 3 x plus 2. Multiply out your bracket, y is equal to root 3 x plus 2 root 3. I'm going to leave it like that, okay? And I know I've said I like it in the form of ax plus by plus c is equal to 0, but I'm just proving that there's nothing wrong with leaving it in this form. Right, collinearity. Sorry, I seem to have some animations on here. So, collinearity are two lines that are parallel and share a common point, so they lie on the same straight line. Okay, now the statement that I'm just about to give you is what we need at the end. Now this is technically one of the hardest marks to get in higher maths because it has to meet certain criteria. For two lines to be parallel, you need to tell me that the gradients are the same, so the lines are parallel. Okay, they share a common point. Okay, and that they must be collinear, and these little words that I'm underlining here have to be in the explanation. So let's take a look at it. Show that the points P, Q and R are collinear. So what I want to do is I want to find the gradient of PQ. Okay, I want to find the gradient of QR, so there's my common point Q. Okay, and then if they've got the same gradient, they are collinear. So PQ is 2 plus 1 over 0 plus 6. So I'm getting 3 over 6. Make sure you simplify it to half. Okay, so I'm hoping to get the same thing here. So 6 minus 2 over 8 minus 0 will give me 6 over 8. No, let's try that again. I'm pausing because I've clearly made a mistake, I'm sorry. And I can't take away this morning. I should have 4 over 8, which will give me a half. Okay, so you would say that since m of PQ is equal to m of QR, the gradients are parallel. Since they share the common point Q, points PQ and R are collinear. Okay, now this next question that I put in flips collinearity round because it tells you that they're collinear in the question. Okay, and we want to find the value of K. Now what do we know? We know that M of AB has to equal M of BC. Right, so there's a good place to start. So let's find the gradient. So K plus 1 over minus 1 minus 1. Okay, let's tidy that up. K plus 1 over negative 2. Right, M of BC, we would have 7 minus K over 5 plus 1. So 7 minus K, tidy it up, over 6. Okay, we know that they two are equal to each other, so let's set them equal to each other. Let's get rid of the fractions, we're going to cross multiply. So we would end up with minus 14 plus 2K is equal to 6K plus 6. Okay, then solve the equation. So minus 6k on here, plus the 14, plus the 14. So I would end up with negative 4k is equal to 20. So k must be equal to negative 5. Okay, right, midpoints. So you'll have seen this formula. The midpoint is the average of 2 points. Okay, so x1 plus x2 over 2, y1 plus y2 over 2. Right, let's have a look at it in action. So if we want to find the midpoint of these 2 points, we would have, again, we want to add the 2x coordinates together and divide it by 2. Add the 2y coordinates together, divide it by 2. So we would get 4, 2. Okay, now we need the midpoint formula for perpendicular bisectors and the median, just in case you were wondering why I was doing that first. So a perpendicular bisector, it sounds fancy, but it just means that it meets at right angles and it cuts it in two. Okay, so it looks like this. Okay, now this being your midpoint of that line. Okay, so you've got a point on the line and then the perpendicular gradient. So to find a perpendicular bisector, let me break it down a wee bit more. We're going to find the gradient of AB. That'll then let us find the gradient of CD by using m1 times m2 equals minus 1, your perpendicular gradient. We're going to find the midpoint of AB because that'll give us a point that lies on the line of CD, and then we're going to substitute it into y minus b equals m bracket x minus a. Now, as you know, we would be worth 4 marks because there's 4 steps to it. So let's have a look at it. Right, sorry, I was just making sure that it was still recording. So there's your diagram. Okay, so what we're trying to do is we're trying to find this perpendicular bisector here. Okay, so we want to find the midpoint and we want to find the gradient. So we'll start off by finding the gradient of AB. So 7 minus 1 over 4 plus 2, that'll give me 6 over 6. Simplify it, it'll give me 1, so that means that my gradient of the perpendicular line is minus 1, and I have to write in since m1 times m2 is equal to minus 1. Okay, I then want to find the midpoint of AB, because it gives me a point that lies on my perpendicular bisector. Okay, so I would have minus 2 plus 4 over 2, and 1 plus 7 over 2. So I would have 1, 4. I'm then going to use this point and this gradient, and I'm going to substitute it into y minus b is equal to m bracket x minus a. Okay, so multiply out the bracket and tidy it up. And that's you finished. Okay, so let's go on to the median. Always think middle when you think median because we want the midpoint. Okay, and then by finding the midpoint, we can find the gradient of the median itself, and then we'll substitute it into y minus b equals m bracket x minus a. Now, as you can see, 3 steps, so 3 marks. Right, let's have a look at it. What we want to do first of all is we want the median from A, so let me give you a diagram. There, it's there. Okay, now you won't always get a diagram, but diagrams are always helpful, so it might help you to draw one out first. Okay, what I'm going to do is I'm going to find the midpoint of CB, because that'll give me M. Okay, so I would have BC, CB doesn't make the slightest bit of difference, 10 plus 4 over 2, and then 2 minus 4 over 2. So I would get 7, negative 1. Okay, so that's M. I then want to find the gradient. I'm finding the gradient of my median, AM. Okay, so I would have minus 1 plus 9 over 7 minus 4, which will give me 8 over 3. It's not very pretty, but that's what it is. So we're then going to use this point and this gradient, and we're going to substitute it into y minus b is equal to m bracket x minus a. Multiply out your gradient, your fraction, sorry. Multiply out your bracket ax minus 56, and then tidy it up. Okay. Right, so last one, altitudes. So always think perpendicular height when you think altitudes. The example I usually give in class is, imagine you're standing at the top of Ben Nevis and you drill a hole all the way down. You're going to hit it at a perpendicular angle. Okay, and that's what it is. You find the gradient of the opposite line, you find the perpendicular gradient, and then you substitute it in. Again, 3 steps, so 3 marks. Right, so let's find the altitude from A. Let me give you a diagram. Okay, so what I'm going to do is I'm going to find the gradient of BC. So I've got 2 minus 3 over minus 7 minus 4. So I end up with negative 1 over minus 11, which will give me 1 over 11. Okay, so my perpendicular gradient, so my gradient of AD is equal to negative 11, since m of BC times m of AD is equal to minus 1. Okay, we're then going to use A and this gradient here, so A being 3 minus 5 and my gradient minus 11, and substitute it in. Okay, tidy it up. I'm going to take 33 away, so minus 28 is equal to 0. Okay. Right, point of intersection. Whenever you're finding the point of intersection of two lines, at that point that you're finding, the x-coordinate and the y-coordinate are exactly the same. Okay, so you're solving two equations at the same time. It has to be simultaneous equations. Now you can do that through substitution, or you can do it through elimination. It's entirely up to you. Now, the most common error is an arithmetic error for simultaneous equations, so please be careful. Right, so first one, exam question, let's take a look at it. The median from BD. So what I want to do of the median BD, I want to find this line here. Okay, which means I want to find the midpoint of AC. So I would have minus 1 plus 7 over 2 and 12 minus 2 over 2. So I would have 3, 5. Okay, now that I've got D, I can then find the gradient of BD. So I've got 5 plus 5 over 3 plus 2. So I'm getting 10 over 5, which is 2. I'm then going to use the point B and my gradient of 2. And I'm going to substitute that in. So I've got y plus 5 is equal to 2 bracket x plus 2. So I've got y plus 5 is equal to 2x plus 4. So I've got y is equal to 2x minus 1. I'm going to write that in here. Okay, so let's drop all this out to give me some space. I'm on to part B. I want to find the altitude of AE. So the altitude AE looks like this. Okay, so I want to find the gradient of BC. So the gradient of BC is minus 2 plus 5 over 7 plus 2. So we end up with 3 over 9, which is a third. Okay, I then want to find the gradient of AE. So the gradient of A is the perpendicular one, so that would be minus 1. And I would have to write in since m of BC times m of ADE is equal to minus 1. Okay, I'm then going to use this gradient, and I'm going to use the point A. And I'm going to substitute it in. So y minus 12 is equal to minus 3x plus 1. Multiply out your bracket. Okay, and then tidy it up. Right, now there's a reason why I'm leaving it as y is equal to mx plus c. Right, but that's what I've got. I now want to find the point of intersection of these two lines. So if I want to find the point of intersection, I'm going to use simultaneous equations. Like I said, you can use it through substitution, or you can use it through elimination. It's entirely up to you. The reason I've kept it in this form is because I'm going to do this one through substitution. Okay, so y is equal to 2x minus 1 and y is equal to minus 3x plus 9. So I can make them equal to each other since they both start y equals. So I've got 2x minus 1 is equal to minus 3x plus 9. Okay, I want to add 3x onto both sides. So I get 5x. I want to add 1 onto both sides is equal to 10. So x must be equal to 2. I then want to sub that back into one of the lines. So I'm going to substitute that into y equals 2x minus 1. And I would get 3. Now it usually always says coordinates of the point of intersection. So you've got 2 out of the 3 marks, unfortunately, because you have to write in that your point of intersection is 2, 3, even though all the information's there. Okay, so last one, we want the equation of the line from the median, the median from C. Okay, so it's going to look like this. Okay, so I want the midpoint of BC, of AC, AB even. So I would get minus 1 minus 3 over 2 and 6 minus 2 over 2. So I've got negative 2 minus negative 2, 2. Right, now as you can see, minus 2, 2, it's a horizontal line. Okay, so if it's a horizontal line, then the only coordinate that's staying the same is that y is equal to 2, and that's the equation of the line. Okay, you can substitute it into y minus b equals m bracket x minus a once you realise that your gradient is 0, and you'll get the same thing out. Okay, so for part B, I want to find the perpendicular bisector. As you can see, it's worth 4 marks because there's 4 steps to it. Okay, so I want the perpendicular bisector of ABC, so that means it's coming through like this. It's cutting it perfectly in two and it's meeting it at right angles. So I want the midpoint of BC, which is minus 3 plus 5 over 2, minus 2 plus 2 over 2. So you're getting 1, 0. Okay, I then want the gradient of BC. So 2 plus 2 over 5 plus 3 will give me 4 over 8, which is a half. And then substitute it in, so I would get y is equal to a half x minus 1. So 2y is equal to x minus 1. Okay, now as you can see, I've now got two equations of the line. I've got y is equal to 2 and I've got 2y equals x minus 1. If I want the points of intersection, I've already got my y coordinate. So that y coordinate then has to be substituted in here to find my x coordinate. Okay, so I would get 4 equals x minus 1. So add 1 to both sides. X has to be equal to 5. So the point of intersection is 5, 2. Okay, so today I've taken you through everything from parallel and perpendicular lines, using m equals tan theta to find the gradient, collinearity, altitudes, medians and perpendicular bisectors, and then the point of intersection, finishing off with some exam questions. If you've got any questions, please speak to your class teacher.